So you see that while we were messing with the cold Morpholine solid, the 47A, which was the liquid from the distillation, has liquefied again as it warmed up. But you'll see that unfortunately this 47B is still being recalcitrant and not coming out of solution. Oops. Try not to drop that in the sink. So, one way that sometimes works is to add half ml of ether or so. Not too much. And we'll just shake that up a little bit. Try to get it to mix well. Actually, I think I'll use the vortexer. Get that mixed nicely. And then sometimes what it takes is a little nucleating surface. And one way to create that little nucleating surface that the thing can then start crystallizing onto is to scratch the sides with a glass rod and create a little glass powder. And then hope that the product will crystallize onto the glass powder. So you got to be a little careful. You don't want to break anything, but just kind of scratch the sides. And then we'll ice that down. And hopefully something's going to come crystallizing out. At least that would be the goal. We're going to need a filter assembly, a Hirsch funnel and the piece of filter paper. Already got my filter adapter. And I've already used the two 25 milliliter filter flasks from that hood, so I'm going to pirate one from another fume hood. Turn that later. So that assembly will be ready at such time as that decides it's going to form a solid. We'll just kind of leave it there for a bit. And while we're waiting, let's get an IR on the liquid. So wake a computer up here. We have our set of sodium chloride plates. Grab a Kim wipe. And a fresh glass stirring rod. Fortunately, there's an infinite supply of those. For some reason, this computer refuses to wake up. There we go. So we'll open up Omnic. And I'm going to make sure there's nothing in there. And there isn't. So we can collect a background. I'm prepared. Please prepare to collect a background spectrum as code for take your sample back out, you fool. And that looks normal. We got our hydrocarbons, our CO2, and our water. It says single beam, so we can close that. We don't want to save it. Cancel. We don't need that either. Alright, so it's all ready to run our sample. We just need to reach in here and get a drop out, put it in the center of the plate. And then stick the other plate on top, create a thin film. These plates aren't great, but I think that's a film that will work. And that's just going to sit in our little holder. Put that holder back in. Trying not to touch anything except with my back of my fingernail because I don't want to put a fingerprint on the sodium chloride plate. And now we can collect our sample and the spectrum title. This was 57A, is that right? Maybe it was 58. 47. 47A. We'll have a -1, -2, and a -3 here because we're going to get GC mass spec and NMR data on this product as well. I'm prepared, it's in there. Taken 4 scans, background age 1 minute. Perfectly fine. So there we go. Looks pretty good. Move that down where it's out of the way. And I will add a comment that says liquid distilled from reaction of morpholine and t-butylacetoacetate at 170 degrees Celsius. So I'll identify what we're looking at, move that in the corner where it's out of the way. No real need to correct the baseline. The baseline's pretty flat. This over here, that's the sodium chloride absorbing. We got a big broad peak here. We got some stuff there. So we want to find peaks. And I want that one at 1712. Not sure what that is. Shouldn't be there. Anyway, so we've got all the significant peaks labeled. We'll replace that. If I want to, I can cut some of this out here by changing my display limits. Since sodium chloride absorbs between 400 and 600, there's no real point in looking all the way down to 400. We might as well make that 600. And then I can probably make the display limit 15 on the, instead of starting at 0. So I can make that take up a little bit more. I could even make it, if we move this out of the way. I could even make it 25. That way it takes up the majority of the screen. Let's move that guy out of the way. So that looks good. We're going to save that. file name to title. And I don't want to be in JOChem, I want to be in JData. So I've saved that. I'm going to print it. Pointing into my folder. (47A-1). Now I want to do a search. Check the library setup and make sure it's pointing at the Nicolay condensed phase academic sampler, which it is. We will search that, and you'll see we're getting an 86.25% match to 2-methyl-2-propanol, 99.5% pure sample of 2-methyl-2-propanol, and the next closest match is less than 55%. That's a good sign, since 2-methyl-2-propanol is what we thought we had. This extraneous peak at 1700 is interesting. Could be acetone from cleaning something. So we'll print those. And I want to call that DCL 47A-1 search. Actually, wait a minute, I'm not saving that, I'm printing it. There we go, we're printing that. Print items on separate pages. (47A1-PDF) search. So that's a good result. And then we want to use the IR spec to identify functional groups, as always. It knows it's an aliphatic hydrocarbon. For some reason, it doesn't think it's an alcohol, even though there's a giant CO stretch here and a giant OH stretch there. So that's not very useful. But we'll print it anyway because we can. And we're going to call it, oh, come on, it'll be a pain in my butt. Computer is having some issues. Yeah, it's angry. I don't know why it's angry, but it's angry. Look at that printer. Yeah, it's in the back there, it's hiding. And it's 47 functional groups. Maybe I can spell that right even. Alright, so that should be everything we need for that IR. Close out, save the spectrum, I already did. Here we go. Cancel that. Oh, it's really excited about something. Put that back to sleep. So I'll upload that to Blackboard at some point. Oop. Be a good idea to take our sample with us. And clean our plates. Normally I wash these with hexane by just putting a drop or two of hexane on the Kim wipe and then wiping off the plate. Kind of wipe the plate on the hexane. So we'll get both sides. Wipe off our stirring rod as well. Those plates can be put away. You'll notice I'm holding them by the edge to avoid getting any more fingerprints on them that are already there. Put that kit back. That's one out of the 3 pieces of data we need to get on the liquid product. We'll be able to get a GC mass spec, and then tomorrow I'll have to wait till the instrument's working again. So meanwhile, the distillate, or the material that didn't distill, has been sitting there in the ice bath after scratching and treating it with ether. And it's showing remarkably little desire to form solid. But now it's ice cold again. I'm going to go back in there and scratch it some more.